In today's lesson, we're going to look at the bubble sort. It's just a method of sorting numbers from the smallest to the largest. The objectives are to understand the term bubble sort and how to manually bubble sort a set of numbers. And you should also be able to draw a flowchart to illustrate an algorithm that will utilise the bubble sort process. After you've drawn the flowchart, you should then create a program that utilises a bubble sort to reorder a set of numbers. And this will be done in Python. So how does a bubble sort work? We take an unsorted array. In this example, we've got 5 numbers: 14, 33, 27, 35 and 10. We're just keeping the set of numbers short because the longer the set of numbers, the more time it takes. So just in this example, again, let's stick to 5. So the bubble sort starts with the first two numbers, or the first two elements, and it compares them to see which one is greater. In the case of this example, the value 33 is greater than 14, so it's already in the correct location. As we said earlier, the bubble sort is going to sort the numbers from smallest to largest, smallest being on the left, largest being on the right. So we know that 33 and 14 are in the right place, so we move on to the next set of numbers, which is 33 and 27. We find that 27 is actually smaller than 33, so these values have got to be swapped. So after we've swapped them, we've now got 14, 27, 33, 35 and 10. We move on to the next set of values, and again we can see that they're already in the right position because 35 is greater than 33. So we move on to the final two values, 35 and 10. And as we can see, 10 is less than 35, so it's not in the right order. So we swap these values and we've got to the end of the list, or the end of the array. And after one iteration or one pass, the array should now look like that. So 14, 27, 33, 10 and 35. So as you can see, we've sorted the list once. However, it's not finished because the numbers still aren't in order. The 10 is sitting in position 4, where it needs to be at the front because it's the lowest number in the array. So all we do is we put this new list back through the process, and we keep going through the process until the list is sorted. So this is how the list would look after the next pass. So the next iteration, it would then move the 10 one to the left, and again after the next iteration it's moved to the left by one value, and finally when there's no swap required, all the numbers are in order and the bubble sort has done its job. So now we know what a bubble sort is, we need to draw a flowchart to represent the algorithm for the bubble sort. Remember the shapes that you used in the flowchart previously, as these are the shapes that you're going to use today. We have the terminator for the start and end, the decision for any decisions that need to be made, a process for something that has to be done, and we use the input-output shape for any inputs that the user might make or any outputs to the display, such as print. So here is the example of how a flowchart might look for the paper-based sorting process that we did in a previous lesson. As you can see, we start using the terminator. Then we get to the first process, which is to pick up the first number. And remember, this was the practical activity, so it was actually picking up the first bit of paper with the first number on. Once we've done that, we then go on to call that number 1. Once we've named that number, we pick up the second number and we call that number 2. So we just work through this flowchart from the top to bottom. Once we've picked up the two numbers, we then make the decision, is number 1 greater than number 2? If it is, we then go to swap the numbers. So we put number 2 in number 1's place and number 1 in number 2's place. Then we change the name of number 2 to number 1 before we move on and pick up the next number. If number 1 is not greater than number 2, so the answer to this decision is no, we'll leave the numbers as they are. And then again, we change the name of number 2 to number 1, and we pick up the next number and repeat the process. Now this works because we are humans and we know that when we get to the end of the list, we need to stop. However, if it's a computer system, the computer doesn't know automatically when to stop, and if it gets to the end of the list, it will still look for the next number because of this process here, pick up the next number. A computer won't understand that there's no number to pick up, so therefore it can't. The computer system would actually probably break if it was trying to do this. So we need to look at an alternative way of working. So, as we said, the previous slide is okay, but it can be improved and it needs to be for a computer. As we said, the algorithm will break as it will still be looking for the next number after the last one, but there isn't a number there. So let's have a look at adding a decision to decide if the program should end or not. The following command will check if the end of the list has been reached. If it has, the program ends, otherwise it carries on. So we can see a decision that's asking if it's the end of the list, and if it is, it will come out and stop the program. So it's now your turn to draw or create, if you're using online software, a new flowchart for a program that will bubble sort a list of numbers. You'll have to create a list of numbers in the program, so this needs to be in your flowchart. Make sure you have the new decision in to check when the program gets to the end of the list. I recommend that you start obviously with the terminator and then immediately create a process that generates a list of 5 numbers. If we go back to the previous flowchart, just remember that instead of picking up the first number and calling it number 1, so instead of this process, you're actually generating a list. Have a good go at this and give yourself about 10 minutes before you move on. Let's have a look at an example of an algorithm that should bubble sort a set of numbers generated in a list. Yours may not look exactly the same, but the outcome should still work. So as you can see, we have our terminator, and then the first thing we do is create a list of numbers. We go to the first number in the list, and then if the first number is greater than the next number, we swap the numbers. If the first number is smaller, we don't swap the numbers, we leave them as they are. We then ask if there's any more numbers in the list. If there are, we carry on, otherwise we stop. So if there is another number in the list, we move to the next number and then move back around the loop and ask, is the number greater than the next number? So this bit here would essentially be our for loop. So now you've got your flowchart completed, it's time to start writing your program. First thing you need is a list of numbers. Remember, a list uses square brackets and elements are separated by commas. Let's create a list of 5 numbers. It's always good practice to add a comment onto your program so that others and you will remember what your program is doing. So if we go into Python, as you can see here, I've created a list called number list, and in that list I've added 5 elements, numbers 10, 2, 5, 0 and 8. I'm then simply printing the number list to make sure that the numbers are stored correctly. So if I now run the program, we can see that the program works and we've added numbers to a list. So let's have a look at the next part of the problem. We're going to need a for loop to loop through the list, checking every number as it goes. the for loop will need to count how many elements are in the list to know how many times it needs to loop. So we can use the len function to work this out. The len function simply calculates the length of the list or anything else that we apply it to. So we're going to use the length function to count the number of elements or the length of number list to set this number here, and then we'll count from 0 to that number. And in our example there are 5 numbers in the list, so therefore this value will be 5 when the program is run. So it will say for I in range 0 to 5, the length of the list, and I being every element in that list. So the 0 element, first element, second element, third element, and fourth element. So if we add this to the program, for I in range 0 to length number list, so make sure we close off both the brackets. Then we need to look at the next command. We need to use an if statement selection to compare two numbers. We're using I as the current number, so therefore I plus 1 will be the next number. I plus 2 would be the number after that, and so on. Don't forget to use the greater than or less than symbols to compare the numbers. And also don't forget to indent your code so that it runs as part of the for loop. So there is the code, and again we've added comments to it. So if number list I is greater than number list I plus 1, so for every time the for loop goes round, I starts at 0, and the next loop it becomes 1 and 2 and 3 and 4 and so on. Let's add this code to our program. If the first number is greater than the second number, they'll need to be swapped. Before we swap them though, we're going to have to store the one that we're going to replace, otherwise we'd actually just write over it with the new number and we lose the number that we need to swap. So we're going to use a suitable variable name, and I'm just going to use temp for temporary to store the value of the number you're about to change. So here we can see we're creating a variable temp and we're storing number list I plus 1, because if the previous selection is true, the if statement, we will need to replace I plus 1 with I, so therefore we need to temporarily store I plus 1 at the moment. So if we go back to our program, so if number list I is greater than number list I plus 1, we need to store this value I plus 1. So we say temp equals number list I plus 1. Now we've stored that temporarily, we can move on and we can swap the first number with the second. So we just say number list I plus 1 equals number list I. Now we've swapped the numbers, we can replace the first number with the one that we've stored temporarily. So number list I equals temp. And that way we've swapped the numbers. So we should now have a program that sorts the list once, i.e. one pass. Let's test it. To see the output of the list at the end, after it's sorted it, we're just going to print it again and then save the program and run. Now we've picked up an error, and we have to look at why we've picked up an error in order to fix it. So if we imagine we've got 3 numbers in a list, and those numbers are 3, 5 and 1. The computer program that we've written says for every element in the list, compare it with the next element to see if it's greater than, and if it is, swap it. So we look at the first element and we say the first element is 3, the second element is 5. We know that 5 is greater than 3, so we can leave them where they are. The computer program then says, well, that's sorted, so we then need to look at the next element, which is 5, and we compare it with its next element, which is 1. So we know that these two need to be changed. So if we just replace that, so that becomes 3, 1 and 5. Now, because we've sorted this element, we move on to the next element. And the computer program is looking for another element here to compare this element with. However, because we've only got 3 elements in the list, we don't have that element there. So the computer has found an error because it cannot compare this number to another number there. So what we need to do is we need to look at how we can restrict the computer from looking for an extra number after this number here. So all we say is when we're working out the length of the list, for each element in the list minus 1. So if we say the length of this list is 3, if we say the length minus 1, that equals 2. And if we use the for loop twice on this list, it will sort the numbers in one pass. So let's go back to the program and have a look. Where we've got for I in range 0 to length of the number list, we actually need to look at this length of the number list here and say, well, we don't want to sort it for every single number in the list. We want to do it for every single number minus 1. So the length of the list minus 1. When we're working out this number here, we need to subtract 1 from it. So we just type in minus 1 there and then try running the program. So we save it and run, and we can see that now we have the original list and we have the new list after it's been sorted once. The 10 and the 2 are swapped, then the 10 and the 5 are swapped, then the 10 and the 0 and the 10 and the 8. So essentially this one pass has moved the 10 from the first element to the last element. It's sorted the number 10. So we need to keep sorting this list until we've got all of these elements in order, because we can still see that the 0 is in the wrong position. It should be at the first position. So that's your job now, is to work out how to make sure that the program sorts every single number.